through exactly how to do each one of these 5 tasks or questions. So let's see what we have here. We have the first one. Define 4 different variables. One variable should be saved to a string, another to int, and another to an array, and lastly one as a dictionary. Screenshot you defining the 4 variables. Now look, there's a few ways. So what you're going to be doing is you're going to be writing code in Python. And what we're going to be doing in this is we're going to be understanding data types. So you could use your text editor to write this down and run it in the console if you know how to do that. But if you don't know how to do that, you can literally just open up a new tab and you can just type in, whatever, Python compiler. Okay, and it'll bring you to a compiler. All you need is an internet connection. Okay, so we have this here, and we can sit here and we can figure out what it is we want to do, right? So here's where you have your environment, and again, you could do this in a text editor if need be. Okay, it's fine. But worst comes to worst, you could at least do it like this, right? Okay, so now let's go back and let's see. Oh, define 4 different variables, right? So we're going to be learning about data types. So basically, whenever you code, one of the key things is understanding what's called data structures or data types. So you could save a variable, you could name something, anything, and your variable should be named uniquely to everyone else because there's no reason why you can't come up with something unique. So my unique variable, it could be anything, right, equals, and this is the way you save data to my uvar. Okay, that's the name of my variable. I'm saving some type of data to this name right here. Now let's see, what do I want? I want to define one variable saved as a string data. So string data is something like this. Hello class, and it's always defined in the quotes. You have to put these quotes around your string data. Now string data, okay, is it has certain properties. So now I have this variable, and inside this variable is the string data hello class. So what I can do is I could use what's called the print function, and I can print my variable to the console. So I run this, and it just says, right, it just says print to print this thing here. Okay, now there's certain things about string data, and all data has different properties, different attributes, right? So what does that mean? So let's see, it says, okay, so we save these 4 variables, okay? We'll go one by one. Well, I should have just said string and then went through the string stuff, but okay, but what's special about strings, okay? String, I could sit here and I could say print my uvar, and then I could put this bracket here, and I could say 2. Now, what does this on the inside mean? So this was the name of my string variable, and then I put these brackets here, and I put that number 2 in. So what this means is that I'm indexing the string variable. You start off with 0, 1, 2. So what's in the tooth spot, or what's in the 2 index, is that letter L, and you'll see that when I click run, it prints that letter L because it's referring, I'm indexing to the second element, or the tooth element, where you start with 0. So that's weird, right? Know that when you're indexing elements in Python, the first index starts with 0. And I could sit here and I could write out, like, all these things, and it indexes, right? So the 7th one is probably that, and then 8 should be A, right? Because it's 0, right? H is 0, 1, 2, 3, 4. The space counts 5, 6, 7, 8, and then the 8 is that A right there. Okay, this is string data. It is indexable. Okay, it is indexable. Okay, now let's see. The next type of variable that I cared about was, okay, an integer. Integer is as simple as it gets. There's complications that can arise when you start doing mathematical operations with just integers. There's rounding errors that could occur, but in general, right, you could say another variable, and again, you guys have to write this uniquely. If these names are all the same for all of you, it's really going to illustrate that you didn't understand. So try and make your variable names unique. So I made it another v, and I'm not going to make it a string, I'm going to make it an integer, so 56. Okay, and then literally I could print to the console that variable, and it's just going to be 56, and it's interpreted as an integer, a number. Okay, and again, there's complications when it comes to the data types and how you use these data types when you do certain mathematical operations when it comes to integers. And then there's other types of numerical data like float, which is a decimal, and so forth and so forth. But what you have here is that if you look, right, I can't index the integer. So if I say 1, right, let's see what happens. Error, okay? File string int ing object. So this data type error. This int object is not subscriptable. Subscriptable, indexable. I should have used the word that they use here, but fine. Okay, subscriptable. That means that it can't be indexed. So I can't index this variable. But if I did the same sort of thing with the string, since it's a different data type, right, and capitals matter, you see it doesn't give me an error. It prints the value in that string. Okay, so you can't index numerical data. Okay, or it's not indexable. Okay, then the next thing is that they want you, or I want you, to define an array. And an array is like the big one, because an array is so useful because, I don't know, it doesn't matter what you name it, right? I call it X, okay? And the way you write an array is that you put these brackets. These are brackets, okay? So it's like slightly to the left of the return button on your keyboard. These brackets, and you basically put any element you want. You could put now any data type as the elements inside of this list or array. Typically, we say array. Okay, so I could put a number, and then I could put a string, and then I could put literally any data type as the elements. I could put another array on the inside, right? That's even more, you know, interesting and complicated, that you could sit here and you could even put an array inside of an array, and that's often done. Okay, so I could literally make another list inside here of something, you know, and then I could put whatever, even another array. It doesn't matter, whatever, you know. And now each one of these elements inside the array is for sure indexable or subscriptable. So the 0th element is just going to give me that 67 right there, right? And then I could do the first one. It's going to give me that string, right? This here. And then what's interesting is that if I put the second one, you have to know that that means this entire array, and that entire array is going to print then. You see right here. And then I could index the array inside that, and I could say, well, what is it? Let's say I want the 6. I think that'll give me the 6. Yeah. You see, because then I'm going, what is this saying? This is saying that I'm indexing to this array right here. And then I'm indexing further inside that array. Very useful property, okay, if you really see. So this is the idea behind data types, that there's a whole bunch of different features each data type has, okay? And arrays are for sure indexable, okay? Now let's see, we got another one. We got one more. Let's see. Oh, and a dictionary. A dictionary is one of the most useful data types. So my dictionary. And again, you guys make this unique. A dictionary is defined with the curly bracket. So the curly bracket is the same key that's used for the rectangular bracket that we did for the array, but only you just have to you have to hold the shift key, and then you can close out that curly bracket, and then everything. Now this is going to be a dictionary. This is the way you tell the computer that you're defining a dictionary. These brackets are very key, right? How you define these brackets is of importance. So I feel like I messed something up in here. What did I do? Yeah, that's better. Now it's bracketed correctly. Okay, good. I would have thrown an error. I deleted no bracket somewhere. Anyway, okay. Now, dictionaries. Okay, what's key about dictionaries is that they come in key value pairs. Okay, so what's a key value pair? So this is a key, and then this will be a value. And literally the key could be anything and the value could be anything. So I made it so the key was a string and the value was a string. But I could have the key being an integer and then the value being an integer. Okay, that's another element. The elements are separated by commas. So you see I separated. This is a key value pair, but then this is another key value pair right here. What do I mean by key value? So you could type in, right, so let's say another, and then the value could be something like that. So what's useful is that then you could reference by typing in the key, and it'll give you the value. So I'll say another, that's a key value that I put inside here, right? And it matches with this right here. And what's going to be returned is the value, this 6,976. So watch. When I print that value to the console, I get this, okay? Yeah, so this is a dictionary data type. It's always like this. Now the question is a good question would be, is this indexable or subscriptable, right? So I don't think it is, because the standard notation is something like that. And if I do that, I don't think it's going to be the proper way. So is it subscriptable? It's only subscriptable in the key value pair way, right? So this is no good. You see key error, because it doesn't find that key. And you see this is a key, right? For this is a key, this 6, and then this is a key. This is a dictionary with 3 listings, three things, right? This is 1, right? Again, commas separate the listings, 2, 3, and they're always in the key value pair type listing, a very useful thing. And literally the data type that you could use for the key could be anything, and the data type that you use for the value could be anything. I could have made this an array, right? I could have made that as an array, okay? So again, very useful idea. Now here's the last question that I'm gonna add right now that I want to go through. So okay, we can go through what dictionary data type is. You guys can do this, okay? But now here's the thing: what is the value of object-oriented programming? All right, I'm gonna try to go through this last question here. So, wrong thing. Where am I? Oh, here we go. Okay, so here's the thing with object-oriented programming. What I did here was I gave you some data types. This isn't all the data types in Python. Okay, these are not all the data types in Python, but these are like the fundamental, 4 of the fundamental ones. What you could actually do though is you can define your own data type built up from these. Okay, you could define your own data type and then literally name a variable with that data type. So my own data type. And you could literally make it like, you see how there was like some notation for a dictionary, there's some notation for an array. You could make your own data type and make a variable with that data type right away. And you could just have, oh, this is my data type. But you would first have to define it. So it's extremely versatile, right? You could sit there and you could be like, actually, I don't like that data type. I want to be able to do X, Y, and Z. And you could define that data type. You could define that object, it's called. So you see, when before I tried to do, I tried to say print another v1, right? And I click run, and you see it says int object. You see, so it's talking about an object. That's where object-oriented programming comes from, because any numerical data, you could say, is given an object of a number, right? Like an object. Anyways, so like basically what you have here is that you could come up with your own objects is what's valuable. You come up with your own data structure and then utilize that as you please.